We've got two exercises today. One of them is an absolute cheese. I'll get straight into it, I think. So 7C.1, we're talking about where there's two possible outcomes. So in the context we've got here, we've got something about a goalkeeper, excuse me. Matt is a goalkeeper, and he has a probability of 0.62 of saving a penalty shot. So he's reasonably good. He's going to save 62% of them. Given 37 trials, so if someone's going to take 37 shots, penalty shots, how many would you expect him to save? Okay, and this is just the expected number is going to be 37, so the number of trials times the probability of him saving it. Okay, so that's how easy this is.
Second YouTube clip.
22.94. So we've got 22.9. That's how many we expect him to save on average. Okay, so that's the expected number on average. If it's said explicitly, like out of 37, how many will he save? Then you would round that to 23. Okay, so this is the number on average, but if the question is asking specifically for a discrete number, then we would round that to the nearest whole number. So yeah, it's 0.5, we're going to round it up. If it's 0.4, it's going to stay at 22. The only other thing to say about this, the way this is different from what I'm going to do over here, is here there's only two possible outcomes, okay? Either he saves it, or he doesn't save it, and it's a goal. All right? Whereas when we come over here, we're still talking about an expected outcome, or an expected number of, expected result, but there's multiple outcomes, okay? So remember, this is a probability distribution. We've got, these are the possible events that it can take. Okay, it could be 0, it could be 1, it could be 2, it could be 3, and then this is the probability of that event occurring. Okay, and what we can see here is there's multiple events. And so because there's multiple events, we're going to use a different formula. Okay, so over here, two possible outcomes. Over here, there's more than two possible outcomes, and there's lots of possible outcomes. So, what are we doing? We're finding E of X. I'm going to show you how we do it manually first. And then I'm going to get into some calculator skills, which will probably take a bit of time, but it's important that we go through some settings on our calculator. So firstly here, this is what we call the mean of a probability distribution. Remember, we've already talked about the median, and we've already talked about the mode. We know how to find them. Okay, now we're talking about the mean. And so the mean, we sometimes call it the expected value of X. So if you're going to repeat an experiment, what do you expect it to be? Or if you're going to repeat it many times, what do you expect it to be? And this is the sum of, okay, if you did 11 spec in semester 1 last year, you know that symbol. That means the sum of each event times the probability of each event occurring. Okay, so this is how simple it is. It is 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 and then plus 3 times 0.1. Now I've jumped ahead and already found K. We did that last lesson. We're familiar with how to do that. All probabilities add to 1. And so K has to be 0.1. So I've filled in that probability distribution problem. We're ready to find E of X. So I'm going to make that whole statement 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 and then plus 3 times 0.1. And we can just calculate that. 0.3 plus 0.4 plus 0.3. We've got 1. Okay, so what that means is on average, the average result is going to be 1. Okay, so let's go through some of these calculator skills then. So that's how you're going to do it manually. Oh, sorry, it does say find the mean, median, and mode. Okay, so this is our mean, and then let's state what's the mode and what's the median. So the mode is the event with the highest probability. That's going to be 0. The mode is 0. That occurs the most frequently. The median is the event when the cumulative probability reaches or exceeds 0.5. So we've got 0.4 plus 0.3 is going to take us to 0.7. So at event x being equal to 1, we have the probability exceeding 0.5. Okay, and we did that one last lesson as well. So we've got the mean, we've got the median, and we've got the mode. of the probability distribution here. Okay, let's look at these calculators then. So what I want us to do, I want us to go into statistics, okay, and we'll go through a few things, all right? The first is, given a data set, how we can use our calculator to find the mean, median, and mode of it. So let's say, for instance, we were to gather the height of everyone, okay? I'm going to keep going back to height because it's a great example, height of all year 12s. And let's say, I'm just going to put in 5 data pieces here. We've had 159 and then 166. So let's say we measured 5 people and we got these heights, okay? So what we're going to do is we could find the mean, median, and mode of that. Actually, I might make sure there's a mode by putting in another duplicate. There we go. We can find the mean, median, and mode just by looking at that. Okay. So the mean is going to be add them up divided by 5. The median, we have to arrange them in ascending order and see which one lies in the middle. It's 5 pieces of data, so it's going to be the one that lies straight in the middle. And then the mode is the one which occurs the most. Okay, so we've got 178 occurring twice. Each other number only occurs once. So let's do that on our calculator then. So what we're going to do is we're going to put all of the numbers in list 1. So we've got 170, we've got 178, 183, 159, and 178. Okay, so then what we're going to do is we're going to press calc, because that's what we want to do. We want to calc, we want to perform some calculations here, so that corresponds with F2. And before we calculate, we're just going to check our settings. So let's press F6 to go into settings. Now there are 2 settings that we're going to be dealing with, and you need to be able to change between both. Okay, you need to change between both because you will use both. All right, we only have information in one list. Okay, so the 2 pieces of information that we should be dealing with, we've got one var x list and one var frequency. Okay, they're the 2 things that we're going to be changing each time. So one var x list, okay, that should say list 1 always, okay, irregardless of what the context is. The only thing we're going to change is the one beneath it, which is one var frequency. Okay? Now, because we only have information in one list, we're going to leave that as the number 1. Okay, so when we have information in one list, this needs to be number 1. Okay? So our setting is correct for now. We've only got information in one list. So let's exit out of that. I just pressed execute to exit out of that. And that's what I'm calculating, 1 there. Tell me some information. And it's going to bring up all of that information. It's got the mean there. It's got the sum of all the heights added together. It's got the sum of the heights squared. It's got the standard deviation for the population. It's got the standard deviation for the sample. Okay, so this is where it's useful having gone over the chapter 6 stuff, because what those symbols mean and the difference between them. Okay, so like this, that means the mean, okay, or the average. I'm going to be doing mu for it. We've got the sum of x, just means the sum of all results. Now the difference between sigma and s, okay, so sigma is standard deviation of population, and s is standard deviation of the sample. Okay, and so what's the difference there? Okay, you guys are a sample of all of the year 12s at Tennyson. So the population would be all year 12s, you guys are a sample. And so if we were going to use you guys to find the standard deviation, we'd be looking at the S result, whereas if we were to measure every single year 12, we would use the sigma result. Okay, N tells you how many results you've got there, how many pieces of information. You've got the minimum, Q1, median, Q3. So med is your median, okay, the one that lies in the middle. 178 is the data piece that lies in the middle. And then the mode is 178 also, and then the max as well. So it's presenting all that information for us. That's how we're going to use our calculator when we have information in one list. Okay. Then let's look at what, that's not what we're doing explicitly today though. That's sort of stuff we've done previously, stuff I would, that's assumed knowledge. So let's exit out, and now what we're going to do is we're going to put this probability distribution in our calculator. So the possible events are going to go in list 1, and then the respective probabilities are going to go in list 2. We're going to have information in 2 lists. So we've got the possible events are 0, 1, 2, and 3. And the probabilities, 0.4, 0.3, 0.2, 0.1. What a beautiful pattern. Okay, we're going to have to go back into settings. All right, so it might be we need to press calc again, but we should already be in there. F2 is calc. We're going to go into settings. Now we've got information in 2 lists. So remember I said this is the thing that's going to change. And we're going to change that to say list 2. Because we're interested in the comparison between the 2. So the way we do that, we hover over it and see how there's F2 corresponds with the list. So I'm going to press list, enter list number, list 2. That's the one I'm interested in. So now it should say list 1, list 2. Okay. Press enter to exit out, and then we're going to calculate that one variant. Okay, it's going to tell you the mean, or what we calculated here. Okay, so we can use our calculator for these things. It's going to tell us the median and the mode as well. Median is 1, mode is 0. Okay, so it's telling us all that information that we can get by looking at it, by doing some calculations, but we can use our calculator to support us. Okay, so what have we learned? We've learned 2 things. If we've got data in 1 list, okay, list 1 and then the number 1. If we've got data in 2 lists, list 1, list 2. Okay? So let's get into exercise today, 7C.1, 7C.2. Much easier than applications of calculus. Oh yeah.
Can I go one by?
That
Yeah.